So this paper is in the area of dictator games where there's giving and taking. Of course, there's been lots of dictator games, all the early literature found that there was a lot of giving, and it was interpreted as evidence of altruism. Later work, starting most notably with the work of Bardsley and List, found that introducing taking opportunities substantially reduces generosity, decreases transfers, and that later work found that this take option effect is robust to adult subjects in Denmark. It's not just university students. The paper I'm going to present today, it's an experiment with small children from between 3 and 7, that actually their patterns of behavior look like those of adults. And it's been found robust to charitable contributions. And then we know what recipients earn more in take games than in payoff equivalent give games, and the payoff equivalent is an essential part of that. Now, the early literature gave all sorts of interpretations of this. It was said to be the Hawthorne Effect, even though the Hawthorne Effect, as we now know, wasn't actually observed in the Hawthorne experiment. And all sorts of things said about experimenter demand effects and artificial environment effects. And then it's finally in Freakonomics 2, it was somehow said to be like the Kina-Genovese case, which is where the New York Times reporters invented all this stuff about 35 people seeing a murder that didn't. I don't know what this had to do with. Somehow John List, I guess, was supposed to be like those reporters. I didn't quite get that one. It seems illogical. But in any case, it really reached kind of rock bottom in interpreting these results as not being serious results. But if you take the behavior seriously, we as experimenters should always question whether there's something we're doing that is not that's somehow just completely artificial. No one questions that. The question is, simply saying that is not doing anything. The question is, if you think that's the case, to then do something about it in how you design an experiment. But if you take the data seriously and really understand theory, then it starts to be really, really important. Because the whole discussion of the literature did not draw the distinction between the implications of convex preference theory, as all graduate students in economics learn it, and maybe pretty much all you learn, like the consumer demand model, and rational choice theory. And convex preference theory is a very, very special case of rational choice theory. And the data is all interpreted as though it was inconsistent with rational choice theory. It just didn't follow, from what was done. Okay, so if you look, this pointer doesn't work, but so I'm tall enough that I can, so this pointer's not working. So here's the data from John List's, one of his experiments. This is the baseline, which is the give only, and take one, where you could also take $1. And this was interpreted as, it's inconsistent. Well, if you look at this, and we know from convex preference theory what it implies. It implies that, see in the take one, all these guys who were taking one, if they can't take one, you know what they're going to be. They're going to be at a corner solution at 0, which would mean, for convex preference theory, that the height of this blue bar, which is the baseline, should equal the sum of the heights of these two red bars. Not even close. So the data are dramatically inconsistent with convex preference theory. But what about rational choice theory? Rational choice theory, there are two axioms. They're Sin's axioms alpha and beta. And if the axioms alpha and beta are satisfied, then choice data can be rationalized by a weak order. That's what you need to know. Okay. The axiom alpha is also known as the contraction axiom. And it tells you the following. It says, if you consider an experiment and where everybody can give all these various amounts and also take one, that the people, when they had the opportunity to take one, didn't do so, that was an irrelevant alternative for them. Contraction is one of the things that's called independence of irrelevant alternatives. There are other things called that also. Well, that tells you something else. What that tells you in this diagram, I'm sure, there should be no red bar that is taller than any blue bar when you look at the contraction set. That's the only one. Those are two observations. So John's original experiment is almost completely consistent with rational choice theory. That's the first thing you need to know. So data from these experiments, and it's also true of the experiments of the various experiments in Bardley's paper, in List's paper, and later this paper by Kaplan et al., where it was run with a random selection of people from the Danish population. So all this data are, quite inconsistent with convex preference theory, all of it almost completely consistent with rational choice theory. So you might say, what's the big deal then about introducing these taking opportunities? Well, the thing is that those experiments were not well designed to stress test rational choice theory. They were well designed to stress test convex preference theory, the very, very special case. So here's what we do. We report an experimental design to stress test rational choice theory. Since that's the big kahuna out there, that's what we want to go after. The paper reports a really nice experiment involving children, a beautiful thing. And I'm not going to talk about that because that's not the most important thing I need to convey to you. We review properties of conventional theory. I've already done a lot of that. But in particular, I'm going to say more about rational choice theory if I can in the time. We develop a modified form of rational choice theory itself, the basic axioms, that includes moral reference points. It explains the so-called contraction effect that I was talking about, that you'd have to have seen in John's early data. It explains the give versus take so-called framing effect, that is the other anomaly besides the contraction effect. It also explains the other major anomaly in this area, which is the earned endowment effect, that people behave differently when they earn an endowment as opposed to playing with house money. And we use data from our experiment, from child experiment data, and also data from college student experiments, which is the Kronik, Milner, and Rossellini data. Oh, the other thing is, in saying that these experiments were not well designed to differentiate, to stress test rational choice theory, the major exception to that is an experiment by Kronik, Milner, and Rossellini. Okay, so here, I'm just going to say a little bit about this experiment. There are 329 children, ages 3 through 7, and we varied the action sets, giving, taking, symmetric, initial endowments, inequality, equal, and envy. Here's what the endowments look like. I'm going to jump to a picture since this is going to really convey what you need to know. Okay, oh dear. Okay, so what you need to do to stress test is you need to get around the space. Most of the earlier experiments were like, this is the allocation to the dictator, this is the allocation to the recipient, and most of it were like done in one corner of the space. So the first thing you do is you need to move around that space. And you see what's going on here. You look at these points B, for example, you see they're moving around. That might be a little hard to see. Here, I'm sure you can see this one. So in this case, notice that the point B has 6 and 6, the endowments of both the dictator and the recipient. Now, in a give-only conventional type dictator game, the endowment is at point B, and the dictator can choose any point between B and A. In a take-only game, the endowment would be at point A, and the dictator can choose only taking, moving up to B. In a symmetric experiment, the endowment is at point B, and the dictator can move in either direction. So those are the elements that you need to have to stress test rational choice theory. The other ones have all that same property. It's just that in this case, the dictator has twice the endowment of the recipient. In this case, it's the reverse. Okay? So here's the setup. Here's this really cool stuff about how you do it with the kids, but I don't begin to have time to talk about that. Okay, the results for take only is the highest point, give next, symmetric down here. Look at that, that's just what adult data looks like. Okay, these kids this young do this. Okay, what is extant rational choice theory? Well, most basic axiom, I mentioned it before and actually I also applied it, is introduced in a paper by Charnoff in 1954. It's called the contraction axiom. The formal statement is, if G is a subset of F, for example, the give only as opposed to give or take, and the choice points in F, called F star, intersection the G set is contained in the choice points of G. That's the axiom. There's one other. This is the only thing you need if the choice sets are singletons. If they're multi-element, then there's a second axiom. This is also known as Sen's property alpha. The other one, Sen's property beta, in his classic 1971 paper. Okay? The words here I've already been applying when I discussed the picture of John's results. Okay, and I'll give you a chance to read that quickly. I already applied that in talking about the graph from the data from John's experiment. Okay, in our experiment, here's what we find. We observe a contraction effect. So the design worked had the ability to find them if they were there, and here it is. Look at this dramatic thing. So if you satisfied conventional contraction axiom, you should not be seeing any striped bar in the contraction set that is taller than any black bar or gray bar. So you see we get a dramatic inconsistency. So the data dramatically contradicts conventional rational choice theory. Okay, what do we do about this? We construct a version of rational choice theory that incorporates moral reference points. By the way, they are objectively defined moral reference points. So we're not, like those behavioral economists, you can see, oh, there's some data. I haven't seen the data. I introduced reference points, and now I can explain it. No, we're committed to these. They're objectively defined by the feasible sets. Okay, if we consider the n equals 2 case needed for dictator games, let's let M be my income, the dictator, Y, your income, the recipient, and the dictator's compact feasible set is F. And now we look at the minimal expectations point. So this is an analog that we're introducing into choice theory that's like what you get in Nash bargaining theory, if you've seen it there. So let's let M0 and Y0 denote the maximum feasible payoffs of the two. And now, given that the other person gets their maximum payoff, what's the maximum for the other person? And then the moral reference point is the convex combination on the horizontal axis of the endowment and the moral reference and the minimal expectations point. Here, a picture's worth 1,000 words. Now maybe you can actually get what I was talking about. So let's look at these things. So notice we've got one of these sets that goes from A to B to C. When the endowment is here, at this point, the maximum payoff for the dictator is 6. Subject to the dictator getting that, what's the maximum payoff that the recipient can get? 6. So the minimal expectations point is here. If theta is halfway between, then the moral reference point is here. Now let's look at the take-only game. You have the same minimal expectations point, but now the endowment is here, halfway between is here, and so the moral reference point is the minimal expectations point. Now look at the take or give game. Now we're talking about this triangle. The minimal expectations point is here. The endowment is here, so the moral reference point is here. Now look what we've got for the moral reference points. This one goes up to here and then across to here. And you say, if there is a axiom that says you get monotonic responses to changing moral reference points, you see what the predictions are. As you go from this case, symmetric, to give only, the moral reference point of the recipient is going up, and so the monotonicity predicts the dictator will be more generous. Here, it's going over this direction, and so you get the same. So this predicts that as you go from this game to this one, that the choice points will track in this direction. Guess what? That's what the literature shows in our experiment and in the Koronic et al. Experiment that actually can test rational choice theory. Here's a formal statement of the axiom. I don't have near enough time to go through that. I'll just tell you that in terms of the two basic axioms of rational choice theory, which are Sen's axioms alpha and beta, what we get are both of them, but incorporated in moral reference points. So we've reconstructed rational choice theory to include moral reference points. Okay. Now, if you look at the predictions of the theory, conventional rational choice theory, so let's let T star, the choice pane is T star when the action set is take, and that opportunity set is AB, the top part of one of those lines. The choice point is G star when the action set is give, and you have the same feasible set. Now, let the choice point be S star in a symmetric action set. The opportunity set is AC, the long line. And now let's assume that S star is within AB, because then you can apply contraction. So conventional rational choice theory says T star equals G star equals S star. Our moral monotonicity axiom says, no. It says T star lies northwest of G star, which lies northwest of S star. And that is exactly the pattern that's exhibited in the data in all the experiments that are able to test rational choice theory, which mainly means ours in the Koronic, Milner, and Razzolini experiment. Okay. So, I see I have 1 minute. So then let me just jump to the summary conclusion. We also do some other stuff. So we have some implications of this for give versus take, and also we show that where the Andreoni and Miller experiment that doesn't involve in giving and taking, but they show that their data can rationalize GARP. We also show that our moral monotonicity axiom implies warp. In other words, it also can rationalize their data. This is a demonstration of this. Okay, if we look at here's where the Koronic, Milner, and Razzolini, where they, being incredibly honest scholars, have their model, and it can rationalize the contraction effect, but then they published an experiment that said, well, unfortunately, the so-called framing effect contradicts our model, and we can explain that because in this case, the minimal expectations point is the natural origin because of the way the sets are. Their endowments start here, give only, and then they go tracking along this line in that direction, and our moral reference points are just going right along in this direction. So it just predicts the pattern in their data. In this case, framing effect, no problem. Okay, summary. Okay, what do we do? Data from List, Bardsley, and Kaplan et al., and also a bunch of other experiments, they don't contradict rational choice theory. They contradict this very strong case of convex preference theory. Data from our experiment and Koronic, Milner, and Razzolini contradict conventional rational choice theory and their own warm glow theory. Our data rationalizes data from give versus take, from contraction, from earned endowments versus house money, and also MMA implies warp, hence it can rationalize the Andreoni and Miller data. And I hope I didn't go over more than by a minute or two, or okay, all right.